Good day everyone, welcome back to our YouTube channel. If you are new to this channel, remember to click on the subscription button so that you never miss on an important update. For our old subscribers, thank you for staying tuned. So today, we are going to be looking at calculus. What do we mean by calculus? Calculus is simply a branch of mathematics that studies the relationship that exists between quantities or variables. It is a branch of mathematics that studies the relationship that exists between quantities or what? Variables. That is what we mean by calculus. This calculus we are talking about is divided into two. It is divided into what? Two. We have the differential calculus, differential what? Calculus, and the what? The integral calculus. So these are the what? Branches of what? Calculus. The differential calculus deals with what? The differentiation aspect of calculus, while the integral calculus deals with the integration aspect of calculus. But for us to have a better understanding of these aspects, let's start with what? The differential calculus that has to do with differentiation. For us to what? Start with differential calculus, there is some key informations that we need to be discussed, that we need to understand before delving deep into differential calculus. And that will now take us to the concept of limit. What do we mean by limit? The limit of a function. Limit of a function. What do we mean by the limit of a function? The limit of a function is simply the value of that function at some input of the function approaches a certain number. The limit of a function is the value of what? Of that function at some input of the function approaches a certain number. For example, the limit of function f of x as x tends to, let's say what, a, is what? Is the value of what? Of this function f of x as it approaches this number what? A. So this is what we mean by what? Limit. So the limit of any function is the what? Is the value of that function as it approaches, as it moves towards a particular what? Number. That is the definition of limit. Under this, there are some key information we also need to understand concerning limits. As we all know, limit is all about substitution. In limit, what we do majorly is what? Is substitution. For instance, of a function f of x, the limit of, let's say, by the time f of x to be 3x plus 2 as s approaches 1. What I do here is what? Is simply what? Substitution. I want to substitute 1 for the value of x in this expression. The limit of 3x plus 2 as the value of x approaches 1 will give me 3 into anywhere I see s, I replace it by what? 1 plus what? 2. This will give me what? 5. So the value of what? The answer to this limit is 5. So what we do majorly in limit is substitution. We substitute the values, but there are some certain rules. There are some do's and don'ts of limits. Under limit, there are some certain what? Conditions. There are some things I'm not expected to what? To have. For instance, if I have the limit of a function, the limit of, let's say, 2x divided by, let's say, x plus 1 as s tends to negative 1. As s tends to what? Negative 1. If I substitute here, let's substitute the value of x to be what? Minus 1. In this expression, we are going to have 2 into minus 1 divided by minus 1 plus 1. This will give me what? Minus 2 over what? 0. This is not allowed in limit. We call this type of what answer an undefined answer. Why? Because the denominator of this answer is what? 0. And because of that, it is what? Undefined. So undefined is not allowed in limits. Undefined is not allowed in what? Limits. Also, what of if I have something like this? Limit of a function, let's say 3x squared over let's say 4x minus what? 4x minus 4. 4x minus 4. Or let's say 4x divided by what? 4x. As x tends to what? 0. Let's see what happens there. I want to find the limit of 3x squared over 4x as x approaches 0. Substituting the value of 0 in this expression will give me 3 into 0 squared divided by 4 multiplied by what? 0. This will give me what? 0 over what? 0. This type of what answer is also not allowed under limit. We call this answer indeterminate. We call this answer what? Indeterminate. So either what? An undefined expression or an indeterminate answers are not allowed under limit. Don't forget, what we do in limit is substitution. But anytime we found ourselves in a situation like this, what do? This now takes us to the rule of what? Limit. There are some certain rules we follow dealing with what? Limit. It is not all about just substituting. Sometimes you may substitute and end up having an undefined answer. This is not allowed in limit. And sometimes we might substitute and end up getting an indeterminate answer. This is also not allowed under limit. So please, let's look at this together. What are the rules that must be followed dealing with what? Limit, in order to get a what? A perfect answer. That is what? That is not undefined, and also that is not what? Indeterminate. So let's look at what the rules of what? Limit. We are going to be stating the rules one after the other. So the first rule we are going to be looking at under limit is the rule that involves a constant. The rule that involves what? A constant. How do we evaluate what? That the limit of a function, let's say k, as x tends to a. So let's look at this. The limit of what? Of k as x tends to what? A. In this expression, our k is what? Is a constant, can be any number. The answer is what? Ck. Why? It is not containing what? X. That means it is only when it contains x that I can what? Replace that x by what? A. You look at this, it's not containing what? X. It means that what? My answer is what? Is still that constant. That is, what are you trying to say? If I have limit of, let's say, 5 as x approaches minus 2. I want to evaluate limit of 5 as x approaches what? Minus 2. If you look at this expression, there is no function of x in this expression. And because of that, we can't substitute x to be minus 2. So therefore, my answer will still be what? 5. My answer will still be what? 5. So that anytime we have a constant, our answer is always what? And our x is not a function of what? X. Our x is always what? That constant. So that is what? The first rule of what? Limit. The second rule, when we have the limit of a constant that is now multiplying the what? A function. Let's call the function f of x. How do we evaluate that? As x tends to, let's say what? A. As x tends to what? A. The rule is that what? Just like what? Our normal substitution, the k should be independent. Then you evaluate the limit of that function that involves what? F of x. As that x approaches what? A. What are you trying to say in this second one? For example, if I'm to evaluate the limit of, let's say, 10 multiplied by what? 10 into what? 3x. As x approaches, let's say, 1. as x approaches what? 1. Limit of 10 into what? 3x as x approaches what? 1. My answer here is what? My 10 is what? Is independent. So 10 into what? You now find what? The limit of what? Of 3x as x tends to what? 1. So this will give us what? 10 multiplying the result of what we are going to have here. As x approaches 1, if I put 1 here, 1 times 3 gives us what? 3. That's 10 times 3, which gives us the answer to be what? 30. So it means that what? A constant is what? Is independent of any function given to you. It stays on its own. It will just what? Multiply the result of that function. The result we got after substituting the limit on what? On that function. So here we have the answer to be what? 30. So please let's take note of that. And also, if I'm having what? Double functions. How do we evaluate the limit of a double function? So let's quickly look at that. How do we evaluate the limit of what? Of double functions? If I have the limit of a function f of x plus another function g of x as x approaches a. As x approaches what? A. It simply means that what? I can split that limit. So that I can split this to be what? Limit of the first one is what? F of x as x tends to what? A plus the limit of the second one, which is what? G of x as x approaches a. What are you trying to say here? You want to evaluate the limit. You want to evaluate the limit of, let's say, limit of 2x plus 5 as x approaches 3. I want to evaluate limit of what? 2x plus 5 as x approaches what? 3. It simply means that I can what? I can split them as limit of 2x as x approaches 3 plus the second one, limit of what? 5 as what? X approaches 3. Limit of 2x as x approaches 3, this gives us what? 6 plus limit of 5 as x approaches 3. Since there is no function of x here, this becomes what? 5. So 6 plus 5 is what? 11. So we have the final answer to be what? 11. Or you can just what? Substitute direct. Just put what? In the value of x. 3 times 2 is what? 6. 6 plus 5 is what? 11. It means that what? We can actually what? Substitute what? Direct. So this is how we evaluate a limit that involves two different what? Functions. One is what? F of s, another one is what? G of what? S. And see, they are not the same. They are different from what? From each other. Okay? And also, sometimes they may what? Give us some limit. They may give us some limits that we need to what? To think critically. We don't just what? Jump into what? Solving. Any question given to you, always what? Look at it carefully before what? Attempting that question. For instance, if you are given a question like this, to evaluate the limit of x squared minus 1 divided by x minus 1 as x tends to 1. Evaluate the limit of x squared minus 1 over x minus 1 as x approaches 1. How do we do this? If I substitute direct, let's substitute direct. Let's say what we have. I'm going to have what? 1 squared minus 1 divided by what? 1 minus what? 1, which is what? 0 over what? 0. This is what? Indeterminate. Indeterminate. And it's not what? It's not allowed. This is what? Indeterminate, and is what? Is not allowed. So what am I going to do? Am I going to leave the answer like that? No. I have to devise another means. So like in this case, we are having 0 over 0, which is what? Indeterminate. I can't just leave the answer like that. So we have to what? Think of another way of trying to solve this limit. Either by what? By factorization, if it's applicable in that expression, or by what? By using what? Another means, another method. So what can we use in this case? What can we use in what? In this case. So let's look at it. Is factorization, is there any factor that can be factored out in this expression? No. There is no factor that can be what? Factored out. in x squared minus 1 over what? X minus 1. But if you look at it very well, this limit can also be written in this form. Limit of x squared minus 1 squared over x minus 1 as x tends to what? 1. X squared minus what? 1 squared. Since this is still what? Giving me this. It means that I can actually what? Write it as limit of, this now give us what? Difference of what? 2 squared. Giving us what? X minus 1 and x plus 1. This becomes what? Difference of what? 2 squared. Divided by x minus 1 as x approaches what? 1. Can you see that? So that this can actually what? Cancel this. So when this cancels this, what are we left with? We are left with what? Limit of what? X plus 1 as x approaches what? 1. So if I put 1 in this remaining expression, I'm going to have my answer to be what? 1 plus 1, which is what? 2. You can see? So when I look at what? The question critically, I notice that what? There is no factor that can be factored out. But I divide another means of solving this. Looking at it that what? It can actually be written in the form of what? Difference of 2 squared. X squared minus what? 1 squared. Which will now give us what? X minus 1, x plus 1. And with that, I get the answer to be what? 2. So this is also what? Another method you can use to solve what? Any problem concerning what? Limit. So look at it. Is there any factor that can be factored out? If no, look at it. Can it be written in form of what? Difference of what? 2 squared. Another question here, if I want to what? Evaluate. Let's evaluate this limit. Let's evaluate this limit. Limit of x squared minus 6x minus 7 divided by x minus 7 as x approach what? 7. So let's look at this limit very well. Let's look at this limit very well. What are we expected to do? What are we expected to what? To do? If I was to substitute directly, what I need to notice as denominator? I'm going to have what? 7 minus what? 7, which is what? 0. And that is what? Not allowed under limit. So look at it. Is there any means I can use? Can it be written in form of difference of 2 squared? No. Can it be factored? Is there a factor for it? Look at it very well. Look at it very well. That means this is what? This is a quadratic what? Expression. So let's what? Find what? Factors. Factors of what? Minus 7x squared. We are looking for the factors of what? Minus 7x squared. And when we add them together, I'm going to have what? Minus 6x. What are those factors of minus 7 what? X squared? So the factors is what? Minus 7 and what? Positive 1. Minus 7 plus 1 will give us what? Minus 6. So you can see this what? Satisfy this. So that I'm not going to what? Rewrite this limit. I'm going to rewrite this limit as the limit of what? X minus 7 and x plus 1 divided by what? X minus 7 as x tends to 7. So when you what? Divide this, we are going to be left with what? With this guy. You can see. So that our answer is now what? When you substitute 7 in this place, I'm going to have what? 7 plus 1, which is what? 8. So my answer is now what? 8. So that's how we what? We evaluate that limit. And also, we may also be given what? Some more complex limit to deal with. For instance, if we are to what? Evaluate. If I'm to evaluate, let's look at another example. If I'm to what? Evaluate the limit of 1 over x minus 1 over 5 divided by x minus 5 as x approaches 5. How do we evaluate this limit? Limit of 1 over x minus 1 over 5 divided by x minus 5 as x approaches what? 5. If I substitute directly, I'm going to have what? In my denominator, 5 minus 5, which is what? 0. It will give me what? An undefined expression. Also, if I substitute here, I'm going to have 1 minus 5, 1 over 5 divided minus what? 1 over 5. This will give me what? 1 over 5 minus 1 over 5 divided by what? 5 minus 5, which is what? 0 over what? 0. This gives me what? It gives me an indeterminate answer. So I must look for another means of trying to what? To solve this. I must look for what? Alternative means of solving this. If you look at it also, can it be what? Be factored? Can it be factored out? No. But since this, what of if I try to what? Define another means by what? Trying to what? Solve for the what? Using what? The lowest common multiple. If I find the lowest common multiple of what? X and what? 5. That is, I'm going to have something like this. Look at it. 1 over x minus what? 1 over 5. What is the LCM of 1 over x minus what? 1 over 5. Now, the result is divided by this. The LCM of x and 5 will give us what? 5x. X cancels x. Remaining what? 5 times 1 gives us what? 5 minus 5 in 5 is what? 1. Remaining what? X. X times 1 is what? X. So I'm having what? 5 minus x over what? 5x. So therefore, I can write this as what? Limit of what? Instead of writing the whole of this, it now becomes what? 5 minus x over what? 5x divided by the big division of what? X minus 5. As x tends to what? As x tends to what? 5. So that if I now what? Solve this, this will give me limit. I can write it as limit of 5 minus x over what? 5x divided by x minus 5 over 1. Isn't it? So that as x tends to what? Positive 5. So that under what? Rule of division, double division in mathematics, when division changes to what? To multiplication, it means that what? The one that is down should go up and the one that is up should come down. This will give us something like this. Limit of 5 minus x over 5x times what? 1 over x minus 5. 1 over what? X minus 5. As x approaches 5. So if you look at it very well, so I'm going to have the limit of what? 5 minus x, which is what? Limit 5 minus x over 5x into what? X minus 5. As x tends to what? 5. So, if you look at it also, this is 5 minus x. This is what? X minus 5. There is something common to them. What if I what? If I factor out negative in the numerator. If I factor out what? Negative in this numerator, it will become what? Limit of negative comes out into what? X minus what? 5. Since I'm having what? If I open up this bracket, minus x plus 5 minus s plus what? 5. That means what? I can what? Factor out what? Negative. Divided by what is under? Divided by what? 5x into what? X minus 5. As s approaches what? 5. So that x minus 5 can cancel x minus 5. Leaving what? Only what? Minus 1 over what? Over what? 5x. The limit of what? Minus 1 over what? Minus 1 over what? 5x. As x tends to what? 5. As x tends to 5, this will give us, if I substitute the value of what? X to be what? 5. I'm going to have what? Minus 1 over what? 25. Minus 1 over what? 20 what? 5. So this is what? How we evaluate that limit. You can see. So we can also what? Evaluate limit by what? By the use of what? LCM. By the use of what? LCM. Also, if I want to evaluate something like this, if I want to evaluate something like this, if I want to evaluate limit of, let's say we have limit of x minus 4 over s squared minus 9 as x approaches 3. If I want to what? Evaluate this limit. If I substitute directly, I'm going to have what? 3 minus 4, which is what? Minus 1 over 0, which is what? Undefined. So I can't leave my answer like this. I also what? Devise another means of trying to what? Solve this. So which other means can I use to solve this? Which other means can I use to solve this? Okay. What of if I divide by what? By the highest power of what? X as the what? Denominator. Why? There is no factor that is what? Common to be factored out. I can't use what? Any LCM here. So that means what? The third option is what? Let's look for a way of what? Dividing by the highest power of x as the denominator. Look at the denominator. The highest power of x is what? X squared. So divide everything through by what? X squared. So I'm going to have the limit of x over s squared minus 4 over what? S squared divided by s squared over what? S squared minus 9 over what? S squared as s tends to what? 3. What I've done is that what? I'm dividing everything through by the highest power of x in the what? Denominator. In the what? Denominator. So please take note of this. Anytime we are trying to solve limit, and when we substitute directly, it is giving us an undefined answer, 1, or an indeterminate answer, 2. Then we can we must use for other means. Which other means? Either we factorize. We can do that by factorization, by looking for the factors, or we can look for difference of 2 squared. Difference of 2 squared. Difference of 2 squares. Or other means by dividing by the highest power. Highest power in the in the denominator. In the denominator. And the last one is by the use of what? Use of LCM. So these are the 4 other ways we can use to solve problems of limit. That is giving us an undefined answer or an indeterminate answer. Either we look for it. Is there any factor that can be factored out? Either at numerator and denominator, or can it be written in form of difference of 2 squared? Either at the numerator or at the denominator, or can I divide by the highest power of the variable in the denominator? The variable can be s, can be any letter. Can I divide by the highest power of the variable that is in the denominator? Or can I use LCM? These are the 4 different ways we can use to evaluate the limit that is giving us an undefined answer like this, or that is giving us an indeterminate answer. So in this case, the only option that we can have is to use to divide by the highest power of x in the denominator, which we use here. So if you do that, I'm going to be left with limit as s tends to 3 of this will give me 1 over x minus 4 over s squared divided by 1 minus 9 over s squared. Minus 9 over s squared. Okay. So we continue. You are going to notice that we are still going to have 0 at the denominator, because 3 squared is 9. 1 minus 1 is 0. So this is still limit an undefined expression. So if I'm still getting this after trying all this, then what is the last step that I can use? Then we call it the use of L'Hopital's rule. The use of L'Hopital rule. So the L'Hopital rule is actually used whenever we devise all possible means, and we are not getting the desired results. We are still getting either undefined expression, or we are getting an indeterminate expression. So in that case, I can make use of the L'Hopital rule. And what is the L'Hopital rule? The L'Hopital rule is only trying to tell us that we should solve that expression by differentiating the numerator and denominator, but using the main method of differentiation. I'm not applying any rule here. I'll just differentiate what is up, and I will also differentiate what is down. I'm not using a quotient rule. I'm only differentiating what is up and also differentiating what is down. That is what the L'Hopital rule is all about. I'm not following a particular rule of differentiation. You can see this is in form of quotient. If I want to follow my normal differentiation, I'm going to use what we call a quotient rule. But under L'Hopital rule in limit, we don't obey what? The rule of what? Normal differentiation. Just what? Differentiate what is up, keep your answer. Also what? Differentiate what is down, keep your answer. Then apply your what? Your limit. So in this case, what are we going to have? So let's try to do that. Using what? The L what? Hospital rule. So using the L hospital rule, let's differentiate what? The numerator. Differentiating the numerator using what? Our L hospital rule. We are going to have, if I differentiate 1, I'm going to have, if I differentiate x, I'm going to have but 1 minus 4 over, if I differentiate x squared, I'm going to have what? 2x. So this is what? 0 because it's a constant. 2x minus 0. Because anytime I differentiate a constant, I'm going to have what? 0. So I'm going to have 1 minus 0, which is what? 1 over what? 2x. As x tends to what? 3. Now, as x tends to 3, my answer will now be what? 1 over 2 times 3 is what? 6. So this will be my final result. My final result will now be what? 1 over what? 6. Using the what? The L hospital rule. You can see, after I have tried the factor method, is not working. Difference of 2 square is not working. Dividing by the highest power in the denominator is not working. I try to use LCM, is not working. Then I will now what? Resort to the what? To the last option I have, which is what? The L hospital rule. Under the L hospital rule, I will differentiate the function normally without what? Using or obeying a particular what? Rule of what? Differentiation ordinarily. You can see, as in this case, this is the quotient rule. I don't obey the quotient rule. I only differentiate what is up and also what? Differentiate what is down. And I'm having what? 1 over what? 2x, which gives me what? 1 over what? 6. And that is the result of this problem.